Good morning, folks. This is Jason Passini with IBM's Hybrid Cloud Sales Team, and welcome to this week's Integration and Development webcast. Now, today we are in part 4 of our Agile Integration Architecture series, and Kim Clark again is going to be joining us to lead today's presentation. Now, if you haven't been able to participate in the first few webcasts in this series, we have covered so far breaking up the ESB. We have also talked about the importance of decentralizing integration. And then last week, we focused on the benefits of containerization. Now, today, Kim is going to be discussing the role of API management within this new integration architecture. And for those of you, too, that may have experienced some difficulty joining last week's session, we have recordings of each of these topics. So if you would like to be added to the box folder where we keep the recordings of all our 2018 webcasts, just shoot me a quick note and I'll see that you get added and you can access all that prior content. Also, if you do have any questions, you can submit them via the chat at any time, but we'll also have an opportunity at the end of Kim's presentation to bounce some questions off him directly. So, you don't necessarily need to hold your questions to the end, but you'll have an opportunity to have some direct interaction with Kim before we do conclude. So with those opening remarks out of the way, I'm going to hand things over to Kim, and we can get started with the latest topic in the series. Kim, all yours.
Thanks, Jason. And welcome back for those of you who've been with us for the 3 parts so far. We're going to step into talking about how API management is affected and related to Agile integration architecture. But first, just a quick refresher of what the key tenets are of this architecture. What makes it specific to the modern styles of application development that sit around it and that it's integrating with. So Agile integration architecture is really focused on enabling greater business agility, just as things like microservices architecture have brought to the application world. And the 3 sort of tenets or aspects of that are around this fine-grained deployment of individual pieces, so breaking things down into more decoupled pieces, allowing the ownership of things to be more decentralized and giving teams more autonomy, so greater development agility there as well. And then finally, all of that sitting on an infrastructure that's more cloud native and very likely to be focused on a technology such as containerization. So that's really where the whole objective sits in terms of the different dimensions. And we've looked at it, we've looked at Agile integration architecture from a box picture point of view, a high-level architecture point of view, and we've broken that down. We've broken that down into application integration. Now we're going to be looking at the API perspective, and then next week we'll be looking at the messaging perspective. We spent some time looking at application integration, and just to remind people what that was really getting into, it was this idea of the ESB being broken up into smaller pieces, smaller containerized integrations, which are then potentially farmed out ownership-wise to individual application teams. And you would have seen this diagram where we talked about the enterprise service bus breaking up into containers. But what I didn't talk to on this diagram was the gray bars, all of the gray bars that are sitting across the diagram that are effectively gateways exposing APIs off of the back of these integrations that have been created, off of the back of the applications that are being developed towards the top of the diagram as well. So clearly, their structure is changing as we move across the different progression from the 4 different stages of Agile integration architecture. And so what we want to do is delve down in the next few minutes as to what that really means and what those gateways are performing and structurally how they're separating out. So we'll begin by talking about API management itself, and we'll just clarify and make sure we're all talking about the same thing when we talk about APIs and how APIs are potentially different to what came before. So what came before, largely in many organizations, there was an SOA initiative exposing web services in a heavily centralized way. Again, this is back to the centralized enterprise service bus, When we move across to a more API-driven, API-led style, we're really talking about not just the fact that we're using potentially a different protocol and data format, so it's often over HTTP, JSON, RESTful requests. That's a different technical style of exposing things, but it's also this much more fine-grained approach to building applications and separating them into smaller pieces. And more importantly, really, the APIs themselves are being exposed instead of by a central integration team. They're potentially being exposed by the application teams themselves. They're taking control of their own ability to expose APIs off the back of the applications or the integrations that they're creating. And along with that comes the ability for the people who are going to make use of the API to self-subscribe to those APIs, to discover them through portals and to self-subscribe. And so it's all very much about self-service and decentralization of control. And so that's really what API management was bringing to the party. Not just a gateway, the grey bars that I was talking about on that diagram, a gateway to perform the security and the traffic management of the requests coming through. Yes, that's absolutely part of providing a managed API, but that's only a part of it, because what we're doing is making this much more consumer-centric, and we're enabling us to say that we can, the internal developers of an implementation can expose their own APIs by going to an API manager capability that allows them to build those APIs into plans and products, as we call them, that expose APIs in a standardized way, in a way that can be found in a portal. So we can go, subscribers can come to a developer portal, view what different APIs are available, what data goes in and out of them, what sort of plans are available for them, and then subscribe to a plan that suits their needs. And we could even potentially charge for the use of those APIs. We've got a very clear understanding of exactly who's using the APIs, how they're using them, got analytics to support that as well, to tell us what's going on from both sides. So the developers who are using the APIs can see their usage of the APIs, see what they're going to be charged if they're being charged, and equally on the inside, the implementers of the back-end system can see the usage of the APIs, see what's popular, see what's being overused, and start to explore how to manage that product going forward. So it's an evolution of where we were with what we had available in SOA. In SOA we had the ESB trying to perform this gateway work, and it was really needed a separate role for the gateway, so that's why that's separated out now. And also the service registries that we had in the days of SOA didn't quite hit the mark in terms of making this use case simple, so that the people in the application teams could expose their own APIs and developers could make use of them easily. So this is a more refined use case, if you like. But there's more subtlety to it than that. As when we start to delve down, we could start to say, well, okay, this looks like what we're saying when we talk about being more fine-grained, is that we're therefore, instead of having one big centralized gateway, that surely means we're going to have lots of individual little gateways against each of our implementations, or maybe even worse still, down to a gateway per microservice. Well, that really isn't what we're saying here. What we're saying is that the infrastructure for performing API management may well still be centralized. It may well still be a single API manager capability, a single portal. It might be a single gateway across a whole different set of implementations. But the different APIs within that gateway can be treated, if you like, in a multi-tenant style way, where the owner of a particular set of APIs has complete control to go in, update, and change the APIs that they have. So they make their adjustments in the API management manager, and those are pushed down onto the gateway in a completely isolated and safe way, so that they only affect the APIs that they're trying to affect. Now, that's not to say we can't break pieces of this architecture up if we want to, but fundamentally, if you look at what API management is trying to achieve, it's more of an infrastructure, a platform for exposing APIs. It doesn't necessarily need to be broken down into individual pieces and at the same granularity as the implementations. But let's have a think about some of the things that could be more granular. So we might, for example, want a different developer portal for one suite of APIs compared to another. So we could break out separate developer portals, for example, for different parts of the user base of those APIs. And indeed, we might actually end up wanting different gateways for another reason, not necessarily because of the implementations underneath, but perhaps because we're doing in a large enterprise, we might be spreading ourselves across a very large cloud, multi-cloud platform. So multiple different clouds, maybe clouds from different vendors. So maybe IBM's cloud, but also Azure and Amazon and Google perhaps. We might be making use of one or more of those cloud capabilities. We might also have the need for an API gateway on-premise in a very traditional way, and we might also have a kind of a cloud internally as well. So be running sort of Kubernetes clusters and things like that in a self-provisioned way, and need an API gateway for those too. So maybe we do need multiple gateways, maybe not as granular as down to the individual implementations, but multiple gateways nonetheless. And if we do, we still perhaps want to manage them all from a central place. So it's possible, therefore, for an API manager to administer gateways, multiple different gateways that live in different environments and live at different levels of being managed as well. We could have a gateway that's fully managed up in an IBM cloud, being directly managed by the API management capability, and then equally we could have gateways that are sitting on-premise that are fully self-installed and self-managed, and so on. So we can have a variation in the degree to which things are managed. And of course, although I've represented the portal and the API manager living up in the cloud, which they certainly can do, we have a SaaS offering for our API management capability, which is called API Connect. The SaaS offering for API Connect is obviously running in IBM's cloud, but you can also run that as an installable capability yourself and install that in any cloud or indeed on-premise, which is very common as well. So we can move these pieces to wherever is most appropriate for the level of management that you want. Ultimately, the technology gives you the flexibility to do whatever you need. Really, the decision should come down to ownership boundaries and good design practices, and of course performance issues like latency as to where things really sit. So we haven't talked too much about microservices so far, so let's dip back into that area of the conversation. If we take a look at traditional applications, it was pretty easy to see what the boundary of an application was. And so, essentially a large siloed application, the server that it was sitting on, that was the boundary of the application. If we're breaking things out into a number of microservices, a number of containers, and an average microservice application could well be in tens of microservices, then it becomes a lot less clear where the boundaries are between those sets of microservices. We know we have a strong decoupling from one microservice to another. That's the whole point. A team can own one microservice and another team can own another one. But surely groups of those microservice components must come together into, if you like, something that we might still call an application, a boundary of an application. And so what is it that's going to enforce those boundaries? Now, if we're building microservices in something like Kubernetes, we've got a reasonable way from a network perspective of creating a subnet effectively for a set of microservices. Things like, for example, the namespace capability within Kubernetes would enable us to build a set of microservices into a group that live together and can see one another across their own network, but they can't see things in another namespace. And so we have that sort of capability is to keep things contained, but then we also need to think about how we then expose that set of microservices to applications elsewhere in an organization, or indeed beyond the organization. And that's really where the API gateway comes back in. So we start thinking about how a particular set of microservices as an application group expose themselves to other groups of microservices. And I've gone to the trouble of describing this in some detail because often when companies are in the early stages of exploring microservices, it becomes just a continuous deluge of microservices being poured out into a platform, and we don't often have the time to step back and think about where those boundaries should be. But once you start to think about, well, when do I really need a governed boundary? When do I really need API management to make a clear distinction between one set of owned capabilities and another? Maybe it's organizational boundaries or business functional boundaries, then that's when the API gateway can really help and hide the implementation of what's going on under the scenes and the complexities of what's going on inside. Ultimately, when you're calling an API, you should have no idea whether you're calling a traditional siloed application or whether indeed you're calling a microservice application. You're just calling an API, and the API gateway is hiding all of that complexity for you. So just to really drill into that, we've got these microservices, microservice components communicating between one another within an application boundary, probably over some sort of a typical API protocol like JSON over HTTP. There are others, but that's the common one. And then we've got communication between microservice applications also going over JSON HTTP APIs as well. So, you know, it looks the same. The communication looks the same, but it isn't the same because it really is going between different domains. And we need to recognize that difference and put some kind of formal gateway in there when we are moving between domains. And it's by doing that we're keeping ourselves safe for the future, to ensure that we can change things and alter things at the level of an application without affecting the consumers of that application. There should be owners, of course, of individual microservice components, but there needs also to be owners at the level of a group of microservices and a group of microservices components, deciding how they're going to be exposed, what the products are effectively that they're going to expose to other domains around the organization. And then the gateway can help to enforce that and also help to automate and simplify the way that other teams can come and use those APIs. So we're back to the self-subscription capabilities, the discovery through the portal. That's the sort of capability that's required when you're communicating to something in another boundary. So we've got this structure now where we've talked about how the gateways are providing the route into a microservices application, into its domain or its namespace, and then we've got invocation patterns going through that domain that potentially then go out the other side into other domains as well. And so we can see complex routing and invocation paths. And there's plenty of complexity to that routing. We've only got to think about the fact that we need to introduce perhaps new versions of microservices. So how do we decide when we route to a new version of a microservice? Which consumers are going to see that? How do we distribute the load across replicated microservice components? So a microservice component might need to scale up from 2 replicas to 10 replicas, and something needs to work out that the load balancing needs to now spread across all 10. Now, a lot of that happens automatically by the platform that you're sitting in. So Kubernetes, for example, has sophisticated load balancing capabilities. It has support to enable you to scale up a particular component and enable the load to be spread across those. But there are more complex patterns that we need to be able to implement within the boundary of a microservice application. And the sort of thing that we're talking about here is things like, how do I do a fault-tolerant pattern, like being able to make requests to a downstream component or an even external system, and if that component isn't available, then after I've tried it 3, 4, 5 times, actually stop calling it for a while and effectively blow the fuse, wait for a while until that system has a chance to recover, and then start calling again. That pattern is known as the circuit breaker pattern, and up to date in microservice applications, the typical way of implementing a pattern like that, a more sophisticated routing pattern, would be to incorporate libraries in the microservice components themselves that catered for, say, the circuit breaker pattern, or enabling routing for more complex things like canary releases, where we perhaps release a new version of the software but only send a small proportion of things across to the new microservice and the rest goes to the current one. Those more sophisticated routing patterns often had to be done with libraries that had to be imported and configured and controlled and coded against within the microservice component themselves. What we're starting to see now is that those have been separated out into some well-known capabilities known as a service mesh. And there's a few different service meshes out there. The one IBM are focusing on the most is called Istio. And Istio enables the routing that's going on inside a microservice application to be controlled by policy. And you have a small proxy on each side of the microservice components, and on the ingress and the outgress to the egress to the application. And so it intercepts effectively all the requests coming through that application, and then you can place policies on them to say, implement the circuit breaker pattern here, or perform a canary release and move across to this new version of this component, or do A/B testing against two different versions so I can see which one is more effective. And so lots of different things that can be achieved by that service mesh. Now, I talk about this because if you look at what the capabilities are at a very high level of what a service mesh does, you'll see things like routing and you know, sort of the types of capabilities that you'd expect to see in a gateway. And so you might start thinking, well, maybe I could be using an API management gateway within the microservice application. But really, that's not the right capability to be using within the boundary of a microservice application. A service mesh is a much more effective and lightweight proxy-based capability for doing it. And the type of patterns that are burnt into the service mesh are the sort of patterns that are needed in that environment. The gateway should still live at the edge. But what's interesting about this is there's a collaboration going on between the API management software and the mesh. Because if the mesh is to enact on policies based on the type of requests that are coming through, it may well start to need information from API management as well. And so what we're starting to look at in API Connect software is how we can embellish the data, the invocations as they pass down into the microservice application. As they pass through the API management capability, the gateway, we enrich the invocation with extra information in the headers. So perhaps which plan am I subscribed to, or what's the application ID, or anything else that's in the context of the information known in the API gateway. The policies can then take advantage of that and start to route things differently within the microservice application. So whilst the service mesh and the API gateway are performing different roles, both routing roles and indirection roles and things like that, but they're different roles, one at the edge of the application boundary and one within, they're also complementary. They're also feeding each other information and swapping information and allowing for perhaps more complex diagnostics and tracing in the future, where we can get a better end-to-end tracing and things like that. So we've been looking at the insides of a microservice application for a while, but I think if we sort of step back to some of the discussions we had around breaking up of the enterprise service bus as well, we can see how all of this is interrelated. This idea of how does API management work against the components that are sitting around it, and these more fine-grained components and the different granularity that it works at. As I mentioned, API Connect is our offering in this space. We see it as part of the overall integration platform, and it's part of the substructure, if you like, of what you're working with in the integration space, and indeed in the cloud-native space. So that's covered API Connect and API management as a concept. Next week, we'll be delving into what's happening in terms of messaging now. API management, of course, and all of the discussions we've had so far have been heavily weighted towards synchronous invocations and synchronous requests, but there is a resurging interest in messaging, especially in the microservices space. So next week we'll be having a look at how that is affecting the integration space and Agile integration architecture as well. And with that, I'm happy to open up to any questions, the usual list of references and places to go and find out more information. Jason, I don't know if we've had any questions come into the chat while we've been talking.
So I think I'm caught up on the chat. Most of the questions that were coming through were folks looking for access to the archived recordings. So again, anyone that did request that, I'll be sure that I get you added to that site today. But folks, if you want to take yourselves off mute, you can pose your questions to Kim now. And while you're doing that, I'm going to be opening a poll question in just a moment or two. So if you wouldn't mind just giving us some feedback, it would certainly be appreciated.
Hi, it's Sam here. I just have a question regarding the stack of the API manager. Can you, I'm sorry, I came a couple minutes late, about 8 minutes late. So did you cover the stack and how it's kind of, how it fits within the IBM WebSphere product suite?
Sure. So perhaps, Jason, if you could give me presenter back again, I'll just show a slide that'll perhaps help with that.
Sure, just 1 second.
My question, excuse me. Sorry, my question once you get there is, what kind of support and maintenance roles and or skills would be required to kind of manage this product, assuming that, because assuming we currently have MQ, I think that's the only, just MQ installed. Like, how would this product be managed? Could the same skills be used by those groups of people to also manage this product, or?
Got you. Yeah. So, and Jason, I still haven't got share right, so I don't know.
You know what it is, Kim? I think it's because I have the poll open. It looks like it's
okay.
About.
No problem. Well, I can talk to it. That's fine. No problem.
Sure, that'd be fine.
So API Connect as a product, let me just describe what that really is. So under the covers, the gateway that I talked about a lot, that's actually data power. That's a capability called data power, which many years ago we bought as an appliance as an XML gateway, and it's been subsequently upgraded to be more focused on script and JSON as well, and APIs. And so that's the superpowered gateway that's sitting underneath it. And it's a very rich gateway, but what we've done with API Connect is provide you with an API manager capability which configures the gateway for you for the specific use case of exposing APIs. And the idea is that it makes it sufficiently simple to configure the gateway for APIs that any developer could come to that and do it themselves. Now, that's not to say organizationally that would be right for you. It might be that you chose to have a particular team administering APIs, but the idea is that we've made the use case for exposing APIs relatively straightforward and more focused around things like, how do I bind these APIs together into a product? What kind of product do I want it to look like? What are the sort of the things about that product that are special? Maybe how many requests per second it has, or what type of security model it has, and so on. But the aim is that you don't have to be an expert in how to configure a data power gateway in order to do it. And the same on the other side as well. So the portal that it then pushes the definitions of APIs out to, it's the portal infrastructure that's put in place, but once it's there, the portal is effectively generated off of the back of the definitions that you've created. So you have a live and changing portal that reflects exactly the APIs that you've got exposed and enables people to self-subscribe again, so that the teams using the APIs can use them themselves.
Tim, you do have presenter rights now, so if there is anything else you'd like to share, you can do so.
I'll take back control just in case, but just checking in with Sam, did that answer your question, or is there more in your head?
So specifically, would it be like web like a web server skill set? Would it be a more of an application SME kind of thing where we have like a business user who understands the various APIs or microservices that we have available, who would be kind of like the subject matter expert around the API manager? What kind of skills would it be? More technical, or would it be more business?
Yeah, we tend to see a couple of roles there, because there is, depending where you're exposing the APIs, if the APIs are being exposed externally to the organization and they really are products that are the new front end, if you like, to your organization.
We would only be about 10% of that.
10% of that.
Maybe even less, actually. As we grow, it would probably be way less.
So that 10%, you probably would have someone involved who you would really call a product owner, and they would think about how those things are going to be exposed outside the organization, potentially how they're going to be charged. But let's also look at your other 90%. So I'm going to assume your other 90% is really the equivalent of what you were doing in the past, perhaps with a SOA program, trying to expose things reusably around the organization, now doing those in more of an API style. Those are going to be being exposed primarily by application teams to application teams. So it's going to be technical people who are probably exposing those APIs, but they don't need a special skill set to do it. It's just they happen to be technical people anyway, because it's technical people sharing with technical people.
So, and we have kind of teams broken down that do different groups of services. So I guess we would have kind of one representation from each of these teams that would provide kind of consolidated or collaborate on how the API manager is, or one person that would communicate with each of those teams to be able to say, okay, are these APIs relevant today, or do we need to? How do we charge back if we're going to start charging our each of the teams, if we're going to start billing them based on usage, that kind of thing?
There's kind of two dynamics going on here, isn't there? Because one is the giving the team autonomy to expose what APIs they want to expose and let them get on with it. And so you definitely want to reduce the friction and have someone from the team able to actually expose their own APIs. But at the same time, there may be things you want to do at a more corporate level, at a more enterprise level. So you might, as you say, want to have a standard mechanism for chargeback that isn't different for every single person who comes to doing it. And so having what they often talk about in the microservices world as a guild that come together from the different teams, and they're all involved in exposing APIs, but they get together to discuss how to do it and try and come up with common methods for doing it.
Thank you.
Pleasure.
Folks, are there any other questions?
If there's not, I have another question.
Sure.
Yeah, far away.
So with the tool, do you guys have like a demo where we can actually see the product in action? What kind of analytics it has, how it does self-service? Do you guys have that capability with this management tool?
Yeah, we certainly do. I think, Jason, I don't know what provision you have for sort of providing links out to people after the conference, and indeed after what you might have planned for future weeks. But we can certainly make sure you've got access to some demonstrations and the like. There's plenty out there.
Okay, thanks.
And of course, feel free to get in touch with your local friendly IBM representative, I'm sure they'd be more than happy to come and show you.
Sure, yeah. One other question. So looking at this slide that you have on the screen, so does the gateway or does the manager sit within WebSphere?
The managers sit within WebSphere. No, it does not. It's a
separate product.
It's a completely separate product, and it's a separate set of running components that do perform the API management. And the portal, in fact, is a Drupal portal. If you know what that is, Drupal's an open source portal technology. We've chosen that because it's very customizable. So we give you a portal out of the box that is already rich in function, but if you want to customize it to your own style, then you could certainly do that. If you want to go and have a look at what that looks like, go and have a look at the Royal Mail website in the UK, because their API capability is built on our portal. I know that for certain. So you'll see from just looking at that it can be customized to a quite significant extent. But no, neither of them are running on WebSphere now.
So is it like does it behave as a web kind of server product? Then is it like that the open source product that you mentioned, or is it more of a client server agent kind of?
I see where your question's going now. Yes. Okay. So is it a browser-based interface that I'm dealing with? Yes, it is. Absolutely. So the API people using the API Manager facility, all they do is go to a URL on their browser, and the same with the developer portal. They just go to a URL on the browser.
That would be running on WebSphere?
No, that's not running on WebSphere. That's running on its own services.
Okay. And then the API Manager, it's connected to the API gateway or gateway. How we implement our APIs. It's going to be. Does it have an agent that kind of keeps track of all of the available APIs, or how are the APIs?
It's a push model. So the API Manager pushes things down onto the gateway, and so when the gateway is running, it's running with a complete set of information, if you like. It doesn't have to go back to the API Manager to get any information, and that's really important. I think there was some back in the SOA days, we did it kind of the other way around, and we did lookups to the service registry to try and find information. And of course, that means that then your service registry has to be highly available, and it becomes another link in the chain.
That's right.
So we've switched that around now. The API Manager pushes down onto the gateway to get the information in there, and so it becomes available at runtime.
Now, for the API gateway, this isn't necessarily an IBM product then, or like it's going to. How's the gateway aware of the API Manager's kind of cataloging of whatever APIs are available?
So the API Gateway is an IBM product. It's data power.
Okay.
Yeah.
That acts as the catalog then of all of our APIs, all of our microservices.
The API Manager sort of holds the catalog, and then it pushes the bits of the catalog information that are needed by the gateway down to the gateway.
Got it. Thank you very much for that clarification.
No problem.
Well, folks, if there are no other questions, I just thought I'd give you a little bit more visibility into what we've got planned as part of the series. So, of course, next Friday we're going to be concluding the Agile Integration Architecture series with more of a focus on messaging. But coming out of the Thanksgiving break, so there won't be a session on the 23rd, and then I believe our next webcast will be on November 30th. We'll be having a demo of the event streams platform, and then the following Friday we'll be having a session focused on Aspera on IBM Cloud Private, or ICP. So if you're just looking to get a better grasp on what we've got planned before the end of the year, that's what we've got coming down the pipe. So again, thank you for everyone that participated. Hope you again found this to be an informative session, valuable use of your time. And hope that you can rejoin us again next Friday. All right. Thanks, Kim. Thanks, everyone.
Cheers. Thanks, everyone. Bye now.
Thank you.